Hi, so we are on page 15 of our Unit 5 packet on polynomials and factoring. Last week that we were together at school, we finished up our section on polynomials, and now we're moving on to factoring. There are 3 types of factoring methods, and today we're going to start with our first method, which is greatest common factor, GCF. So if you notice in today's vocabulary section, there are 2 ways that factor is being used. One is when it's being used as a noun, it means the terms that multiply together to make something larger. And factor as a verb is to break apart into terms with multiplication between them. So we're going to be using factoring as a verb. So how to factor using GCF: determine what number or expression is in common, may be divided out of each term. Then you divide all terms in the expression by the greatest common factor. You will then place the GCF outside the parentheses and place whatever is left over after dividing inside the parentheses. You should be able to distribute your final answer to get back to the original expression. All right, so we're going to walk through this by using examples 1 and 2. So let's go down a little bit. And if we're starting with number 1, looking at this 5a squared minus 15, what would be the common factor? So if you're looking at the coefficient here of 5a squared, 5, and the number 15, something that they have in common, greatest common factor between 5 and 15, is actually 5. So we could write that out. That's a horrible G, sorry. Okay, so the GCF here is 5. Then I would divide each of these terms by 5. Okay, and then they were saying, like with number 3, paste the GCF outside the parentheses. So if we took our GCF and created a parenthesis, basically what we're saying is that 5 times what's inside the parentheses is going to give us 5a squared minus 15. So we're actually doing the reverse of distribution property. So here, 5a squared divided by 5, well, that would just leave you with a squared. I'm going to bring down my operation, and 15 divided by 5 is 3. Okay, this would be my answer, and if I were to check, and I were to distribute the 5, I would get 5a squared minus 15, which is the original expression that we already had. Okay, let's look at number 2. Let's try this one. So 10x minus 25x squared. Well, what would be their GCF here? Now, if I'm looking at the coefficients 10 and 25, I could say that the GCF between those two is 5. And if I notice, the variables are both x's, so I could take 1x. They both have at least 1x in common. Okay? So if I would divide each of these terms by 5x, and then I would create 5x, and then what would be left over, which goes inside the parentheses, well, 10x divided by 5x would leave me with 2. Bring down my operation. 25x squared divided by 5x. Well, 25 divided by 5 is 5. And x squared divided by x. Remember, when you're dividing, you subtract the exponents. So 2 minus 1, leaving with 1. So I could just put x. Remember, the exponent of 1 is invisible. That would be my answer. And again, if I were to check it, Okay, 5x times 2 would give me 10x. 5x times negative 5x will give me negative 25x squared, which is exactly what we originally had. Okay, thanks. See you next time.